Okay, let's consider this reaction. We have methane giving acetylene and hydrogen, and the equilibrium constant is 0.02 at 1700 degrees centigrade. So say we start with 0.01 molar of CH4, and we want to know what the equilibrium concentrations are for this reaction. So let's define an extent of reaction. So I will let X equal to the amount of C2H2 formed. Now I could let X be the amount of CH4 reacted or the amount of H2 reacted. But it's easier algebraically if you pick something that has a 1 in it in the balanced equation as a coefficient, because then everything's related to a whole number instead of a fraction. So if X is the amount of C2H4 formed, then this is going to be plus X. Then the amount of hydrogen that's formed is plus 3X because of the 1:3 ratio. And the amount of CH4 that is reacted is 2:1, so it's minus 2X. So those are the changes from the initial amount. So at equilibrium, if I write the equilibrium constant, this is equal to the concentration of C2H2 raised to the first power times hydrogen concentration raised to the third power divided by CH4 concentration raised to the second power. And so initially there's no product, only reactant. So this equilibrium concentration is going to be 0 plus X. Hydrogen equilibrium concentration is going to be 0, starting amount, plus 3X cubed. And then the equilibrium concentration of CH4 is going to be the amount I start with, 0.01 molar minus 2X, and I have to square that. So this is our equilibrium expression. I'm going to have 27x to the fourth divided by the denominator, okay, so now you'll notice that I have an x to the fourth. I have a quartic polynomial. So I can't solve this by hand by using like the quadratic formula. So what I would do in this case is I would use a polynomial solver, and your calculator will probably do it if you have a modern calculator, or you could go to the web and find a polynomial solver. And as students at Ole Miss, you can use the program Mathematica for free. You can download it. It has a polynomial solver, or you can use Wolfram Alpha. It's free on the web, and it has a polynomial solver. So you could just put in this polynomial, set it equal to 0.02, and solve for x. And doing that will give you the following x values. So these are the values of x that I got from my polynomial solver. Let's see which value of x is applicable to our model. So at equilibrium, the concentration of hydrogen is equal to 3 times x. the concentration of acetylene is equal to X, and the concentration of methane is equal to the initial amount, 0.01 minus 2X. Okay, so if we put this value in for X for methane, we'll get a negative number. So this won't work. If we put this value in for methane, we'll also get a negative number. That won't work. And if we put this value in, it will work. We'll get 0.01 minus 0.00892. Okay, so that's a positive number. Now, so this one works. If we use the negative number, we get negative concentrations here, and so this one doesn't work. So this one is the only X value that works to give me positive concentrations for all three things. So these are my equilibrium concentrations. So we have 0.0046 molar for C2H2. And we have 0.014 molar for hydrogen, 0.0008 molar. So we can use a polynomial solver when we have more than a quadratic expression. And it's easy and fast now. So we can calculate the equilibrium concentrations for even complicated reactions.